Fuad Aleskerov will start the session from HSE University, and he will speak about G-Simon satisfaction principle, superposition of choice functions, and the search problem. Fuad, the floor is yours.
Thank you very much, and thank you for the invitation here. This is a fundamental problem which was under study for many years, and in fact, there are three problems here which joined in our work. And the problem is that due to the exponential growth of amounts of data, the algorithms in search problems very often use obsolete approaches, and they are most of these search engines today are human sensible. And then I would like to go very fast from the classic notions of how people choose, you see, because these very models are create the basis for all kind of models of search. And in 18th century, John Hobbes talked about maximization of power. John Priestley and John Bentham talked about maximization of happiness. And only in 20th century, John Stuart Mill talked about maximization of utility, and Wilfredo Pareto introduced the notions, the concept of maximization of ordinal utility, and this was developed by von Neumann's expected utility models. And the very idea of this approach, which became a fundamental in economics, in psychology, etc., is that to which extent we can compare pairwise, make a pairwise comparison of objects, and we choose being based on the pairwise comparison of objects. And the very idea was that this very preference, we say that the object 1 is more preferable than object X is more preferable than object Y if utility of X is greater than utility of Y, and the solution to which properties should satisfy our P were given by Schroeder and Georg Cantor. I'm sorry, it's not 1985, but it is 1895. In fact, you see, the very basis of this approach was that we can separate objects into classes. Inside classes, they're indifferent, and there are preferences among classes from highest class to the lowest class, but these are mathematical properties of this relation. But Henri Poincaré and Samuelson, in his work of 1938, Samuelson was a Nobel Prize winner, one of the fathers of modern economics, and other people, they created the concept in which they showed that it does not satisfy, in some cases, the situation does not fit the classical concepts of rationality of this pairwise comparison. And Norbert Wiener, the father of cybernetics, introduced the concept of utility with error and studied this. And I can say that he and Richard Duncan Lewis did a lot with these simple types of utilities, and I introduced much more generalized concept of utilities later on. But I would like to attract your attention to the concept which was introduced by Herbert Simon. Herbert Simon was one of the most influential economists of 20th century, and in 1956, criticizing the classical concepts of utility, he wrote that people never choose being based on the pairwise comparisons, but rather they have a satisficing level and they choose everything which is above this satisficing level. I don't have time to go to the details. This is the very concept I formalized it in 1995. And how choose this satisficing level? It might be, for instance, average level on the set, or half of the minimum plus maximum level, or some predefined level on this very set. And it turned out that this very classic model, this very Simon's model, is reduced again to the pairwise comparison with epsilon, but epsilon now depends on the set under study. I will not go in this very direction, and rather will tell you a few words about superposition. Kolmogorov and Arnold were my teachers in the mathematical department of Moscow State, and I studied the problem. First, it was a Hilbert problem, Sutin's problem of Hilbert, and the question was to which extent this superposition preserves the good properties of real-valued functions. And the answer given by Kolmogorov and Arnold in 1956 was that no, they don't preserve it very well. And I studied this very problem from the different point of view of superposition of choice function. And then I returned, it was absolutely theoretical work. It was next attempt was made by my PhD student, and we published and the idea is very simple. We have initial evaluation on the set. We construct choice functions with respect to this very Simon's approach, and then we choose the choice of some level is becomes a set for the other level, etc. We choose sequentially. And the idea is that we have these alternatives which are evaluated by the set of criteria, set of parameters, and we should construct some kind of ranking over alternatives. This is the idea. This is the initial set. We choose something with respect to this satisficing principle. Take these chosen elements, apply second function, third function, etc. And there are many different ways how to work. Today I will talk only about super-threshold model. And this very approach was applied to several models, to several applied problems. And first one was Latour. It was this very data set provided by Microsoft with 1,175,000 documents, 136 factors. And we applied this very set to our method, and we got, for instance, 84% accuracy, with comparing 49% of accuracy by support vector machines. And moreover, well, I will tell you about it. So another approach, another application was in the searching large network retail data with 1.5 million people, and the daily data of their purchases in the supermarkets of this very large network shop. And again, we got much better results than any type of analysis made before. And the third one was this tornado prediction, which is very new. It was published, I think, this year or last year on tornado prediction. And important part of the story is that it is the algorithms are linear, you see, so you can apply them to any complicated and large data sets. These are our publications on this very topic. And these are copyright certificates and patents. And we got, in 1919, we got American patent for this very method. And a few years before, we got a Russian patent to this very method. And we have also these certificates of intellectual property rights. Thank you. And I'm ready to respond to your questions. Usually I talk about this very model 1.5 hours at least. Okay.
Фауд, спасибо большое за доклад. У меня такой вопрос. Вот вы ссылались на работу 95-го года. Это было, кажется, достаточно давно. И вопрос такой.
Thank you so very much for the work. You mentioned the work from 1995. Is it still relevant and topical in view of how neural networks developed?
Yes, certainly. I will respond in English. The story is the following. You see, that for neural networks, I do not understand what will be the result. Here, I understand what are the principles on which it is based. And 1995 results, you see, well, today we use even in neural networks some kind of algorithms based on integrals, etc. But integrals were introduced in the 18th century. You see, we don't say that it's out of time. The same thing is here. You see, in 1995 was made absolutely theoretical problem, was analyzed. In 2008, it was a pure theoretical problem. But now we applied it, and the idea was that, you see, when we analyzed this data a few years ago and applied different ways, random forests, support vector machines, etc., everything worked very slow. And then I suggested to apply this very method, and it worked very well, and you saw the results, you see, much better than other methods. Thank you.